Welcome back to CJay's video notebook. This is part 4 of our DOL motor control basics series. In this video, we dive deeper into motor control flexibility, exploring jogging circuits, selector switch control, and relay-based logic designed for greater precision and safety. Each circuit you'll learn today is another step toward mastering real-world industrial motor control. Stay focused, because the techniques we cover here are essential skills for any serious technician or engineer. This is a direct online, or DOL starter circuit, the simplest and most widely used method for starting induction motors. The three-phase power supply enters the system through a protective circuit breaker, then flows to the magnetic contactor. From the contactor, the line continues through the overload relay and finally reaches the electric motor. On the front of the contactor, you'll notice two wire terminals labeled A1 and A2. These are the coil terminals. When a control signal output voltage is applied across A1 and A2, the coil energizes, pulling in the contactor to close the main power circuit. In the upcoming slides, remember this key point. The signal we'll refer to as S1 output corresponds to the activation of this magnetic contactor. It's this S1 output that energizes the coil via terminals A1 and A2 as illustrated here. This control circuit, jogging with two-circuit push button, introduces a jog function using a two-circuit push button. In this setup, the motor runs only while the jog button is held down and stops immediately when released. This prevents the holding contact from keeping the motor running. It's perfect for positioning tasks where the operator needs precise, short bursts of motor movement. When the jog button is pressed, coil S1 energizes, but the holding path is disabled. Release the button, and the motor stops instantly. In control circuit, jogging with two-position selector switch, we add a two-position maintain selector switch to choose between normal run mode and jog mode. In run mode, the start button energizes the motor and uses the holding circuit as usual. In jog mode, the holding circuit is disabled, making the start button act as a jog push button. Notice, here, we don't need a second contact on the push button. The selector switch handles the control logic by completing or breaking the holding path. Control circuit. Control relay jog for added safety makes the jog function safer by adding a control relay. In earlier jog circuits, fast finger movements could accidentally re-establish the holding path before the contactor drops out. Using a control relay eliminates this risk. When the jog button is pressed, only coil S1 energizes temporarily. No holding circuit is created. In run mode, pressing start energizes the control relay CR, which then properly manages both the motor coil and the holding circuit for safe, reliable operation. Control circuit. Alternate control relay jog circuit is a variation of the relay-based jog circuit. The difference? This time, we don't use the motor starter's auxiliary contact in the holding circuit. Instead, only the control relay CR manages the logic. This simplifies the wiring but slightly reduces feedback about the motor's real running status. If knowing whether the starter is truly engaged isn't critical, this simple method works just as well for jogging applications. And that concludes part 4 of our DOL motor control basics series. Today, you learned how jogging circuits, selector switches, and control relays provide precision and safety in motor control setups. Every circuit you master gets you closer to professional-level skills in electrical automation. But get ready. Part 5 is where things get really exciting. We'll tackle interlocking two motors to prevent simultaneous operation, reversing motor starters, time delay reverse control, and even limit switch integration for precise travel control. Make sure to like, comment, and subscribe to CJay's video notebook so you don't miss out. Thanks for watching, and I'll see you in part 5.